Hi, everyone, and thank you for joining our call today. Today, the topic of our call would be a couple of details on Alluvium. And Maxime, when you're ready, you can just start sharing your screen.
Yes, I already started.
Yeah, perfect. We can see it. So go ahead.
Uh, Oops, it's wrong order. Yeah. Do you see my screen?
Yes, everything is good.
Okay. So today I'd like to have a very short demo on the progress of development of RGB programmability features. Last call, which was actually 3 weeks ago, we were talking a lot about how the RGB programmability will look in the future when we will have a complete tool chain and more user-friendly high-level language, which we call Contractum. Today, I would like to continue the topic of that last call and show what we have today already. So not that language which is still under development and will be completed only after the RGB release, but more low-level stuff which can be used and should be actually used today to develop RGB smart contracts and the stuff that I have created for writing the initial smart contracts, which will be part of the overall RGB release, like RGB20 fungible tokens and many NFTs. So the what it is, as I already was presenting, the Alluvium will be a virtual machine used by RGB, and it is specially designed virtual machine for the needs of client-side validation. So we have several calls where we did a comparison of Alluvium to other alternatives, including EVM, VASM, LLVM, even Java Virtual Machine. And we have seen on that calls why we actually need a specifically designed virtual machine for the client-side validation needs, where we don't need a random memory access, where we can do formal verification much easily, which wouldn't run into exceptions and so on and so forth. But how to program that virtual machine before we have this high-level contracting language? Well, you have to program it with an assembly. And the initial Alluvium release, which we did in June, it had very limited capabilities of writing assembly because it was based on the Rust domain-specific language, and you had to use Rust macro system to write Alluvium code, which wasn't very useful and very simple to do. So during July, I have created the language itself, low-level assembly, which converts into Alluvium instructions, where each code, each mnemonic, each operation is a single instruction of Alluvium language, and additional features of language which allows you to create procedures which called routines or functions, use libraries, commit to the used instruction set extensions. For instance, for RGB, we will be using RGB instruction set extension, and so on and so forth. This language is called Alluvium. I didn't spend much time on thinking about that. And additionally to the language itself, we have some quite simple syntax highlighting for IDEA environments. And I did a compiler, assembler, which converts this text representation into object code, and a linker, which allows you to assemble multiple compiled files with appropriate functions call into a single binary, which will be actually part of RGB smart contract and will be used by RGB node and RGB core libraries to validate the actual state of the smart contract. So this all have been completed, and it's a big relief for me because for now, at least at the low level, there is complete set of tools required to create arbitrary smart contracts for RGB. And I'd like to do a demo in the actual environment, how this thing looks like, and how it works. So there is a repository called Alluvium. It is you can see it if you will go to Pandora Core website and open an Alluvium repository. We have done already a first release of this thing, so this is a released thing, and it is released under the terms of open source license. So if you clone this repository, you will be and open it as a project in the development environment. You will have, of course, the code of actual assembly and linker binaries and pipelines composed of parser, linker, compiler, analyzer parts, and different model for the language representation. But you actually don't need that. What you will be interested most of all is examples folder, where you have several scripts written in Alluvium, which can be compiled and tested against. And for the compilation, we have here a script called code build, which actually use Alluvium and linker to first compile and then link the libraries. So let's start with the code. So this is how it looks like. We have two routines here, which perform different operations. And this file will be compiled. It's a Pedersen Alluvium. It implements the verification of the Pedersen commitment, and it will be compiled into a library. These two functions, the first function called sum, it sums a public key of Pedersen commitments and returns the sum of this public key. Basically, if you have a certain set of amounts as input amounts or output amounts, and you need to compute the sum, this is the routing that you should use. And in comment here, we have the definition, which arguments it takes, AluVM registers, and how it returns the result, in which registers it returns the result. And the verify function, which compares the sum of inputs and the sum of outputs and verify that they are equal or fail verification otherwise. The same here, if the Pedersen are not correct public keys, the function will fail the whole verification process. So this is a library which can be used from different smart contracts. And let me show how it can be compiled from the command line. Today you can install Alluvium by doing cargo install Alluvium program command, and after that you will have Alluvium and link commands in the command line. So for now I will be using my local installation, and the files are in specific directory here. So I'm compiling this this example, Pedersen, and it is compiled. That's how it simply looks. And the compiled object is a Pedersen AO file in the objects directory. We can look into it. We will see that hex dump of build objects is this. It's a very small one. It exports two functions, and this is the actual code that performs Alluvium instructions. We can also supply more flags to the compiler to make it more verbose and explain us what it does. Give me 1 second. if more verbose, we will see that when it compiles, it creates the module that contains the commitment to the instruction set. Here we use SecP elliptic curve extensions to work with the public keys. It doesn't have any data segment, it doesn't use any external libraries, and it exports to functions with this entry point. So this is pretty much similar to the, this part is similar to the Ethereum ABI definition for the smart contract. Now, when we are going to use this library, we will need to create another code, and here another Alluvium file called RGB20, which is basically a verification code for any RGB20 fungible token smart contract. And this code uses the Pedersen library, and here I give a name to the library in the library section, and I have to specify the specific library ID, which is expressed as a backend identifier string starting with ALU1. And this string is created during the compilation process of that library. Here, I need to specify more flags. I don't remember why it doesn't. Anyway, okay. I taken this from the compilation result of the Pedersen library before. And this string is unique to this code. If you will change any single instruction here, you will get another identifier, meaning that you literally commit not just to the version of the library, but to exact code of that library. And this allows you in the client-side validation environment to be sure that there will be no breaking changes when some library is updated. In the Alluvium world, there is no concept of the library version. There is just a library ID, which is commitment, cryptographic commitment expressed as a base32 string to the actual code of the library. And again, I have two functions here, and I have a main verification function, which will be used by the smart contract to do verification of the commitments. And the way this function performs verification, it creates a sum of inputs, which uses in return the function from Pedersen library to do the sum. And then it calls to the Pedersen verify function at the very big end. And if everything went smoothly, it succeed verification. So the same way I can compile this file and then compose a RGB binary code that will be part and will become the part of RGB smart contract. To do that, I will run this code build script, which does all of that for me in automatic manner, and which also includes the linker instructions. And when I run it, I see that it compiles all the source files present in the directory of examples. For each file, it prints out the details of the compilation process. And when I do the linking, like here, it takes two different libraries with their respective IDs, and it links all these libraries into a single binary file. So at the end result, I get these binary files for the set of examples, and this specific binary file actually represents the library that will be used by the RGB to do the code verification. And here, yeah, here we have this library ID. So basically, that's all. I understand that this is a very, very low-level thing. However, it already unlocks an ability to express. It's hard to program assembly, but those who used to that, they will already have ability to compose upon the release of RGB whatever smart contracts they will need to create without waiting for a high-level language development to be completed. Also, I would like to say that this assembly language is quite smart one, because it is designed after the Rust compiler, and it contains very detailed reports on any compilation errors, such that it simplifies the hardness of assembly development. For instance, if I introduce some method, some mnemonic, which is not part of the assembly, and I will try to compile this file once again with assembly. It will report the specific instruction, unknown operation mnemonic, and where this instruction is present, printing even some excerpt from the source code. If, for instance, I will use unknown register name, it will also detect it and say that there is no such registry in Alluvium as I just typed in. Or if I will use a registry outside of the range of the allowed registers, I will also get the error that index is out of the range, and the range should end with a 32. So this is quite advanced system, which actually works. And I welcome all early enthusiasts to play with the language and the compiler. So that's the small part of the presentation, which I was going to show today. And I'm happy to answer any questions.
Wonderful. Thank you, Maxim. Guys, question time.
Are there any examples of RGB contracts that are currently working, or is this stuff merged into mainnet, or not mainnet, but into the master branch? Or can you talk about that?
Well, like you can't merge the language into the master branch of the system. Like Solidity is not part of the Ethereum virtual machine. It's just a tool to program smart contracts for EVM. So the same here, it's a language which you can compile into binary form, and it is the binary form which becomes the part of RGB smart contract. So like C language is not part of the Intel processor. So it wouldn't become part of the mainnet or merged into the master, because it's a thing that exists by itself outside of the RGB core. It's a tool for the developers.
I see. So that gives me the impression then that it does it works though. Like right now, you could use it to make some kind of contract.
Yes, it can be used, and I am using it right now to finalize our release, such that it will operate with the Alluvium. The RGB will use Alluvium itself. But to write the program for Alluvium, I can, of course, write the program in bytecode, like in binary form. But it's really easy to make some mistakes there, and nobody can read it, and it's just possible but not usable. And that's why I created this assembly language, such that other people can understand what this program does, and those who are comfortable with writing, have experience of writing low-level code in assembly or C, they will have at least some tool to develop smart contracts before the more complex but high level and usable languages for RGB are created.
That sounds like a pretty cool way to build out the stack.
To what?
Build out the stack of tools to
yes, it's just the first step on that way of building the tool chain and stack of tools for RGB. Very low level though, but we have to start with something. And actually any other language for RGB will use this tool chain to compile, because any language compiles first to assembly, and then it will use this tool chain that I just shown to create an actual binary.
So the other part of the question was, is there a GitHub with some example contracts of things that you or others have written that compile to something that you can execute, or execute might be the wrong word?
as far as I'm aware, nobody yet written smart contracts for RGB because nobody knows how to do that, and nobody have tools to do that. So actually, this is the tool I released last month for others to start playing with the stuff. The repository is this one. You see my screen?
Yeah, I see your screen.
Yeah, the repository is this one, and here in examples, there are actually examples of the Alluvium code, which is used by the smart contracts. And if you need to, I will send to the chat this first link. And if you need to see how the smart contract looks like today, you should go to the RGB core. This repository. No, actually, I have created the separate repos for the RGB20. Yes, this repository. Again, I will send it to the chat. And here,
I see an RGB20 AluSM file, and I also see an RGB20 GitHub. What's the relationship between those?
It's two different things. The RGB20 GitHub is actual schema. Here we have a schema definition of RGB20 smart contract. So the smart contract is made of schema and Alluvium scripts. The schema is written this way, and this is example. And the code is linked to the schema after compilation in binary form. So the code of Alluvium is compiled into the binary form as I just showed during this presentation. And it is later used by the schema of RGB20. It's still very inconvenient, but at least it is a human language, assembly and the schema language. As I was presenting on the previous time, it will be much simpler in the future. So this is how the contract will work in the future. And this contract will compile both into schema and Alluvium assembly. So everything will be automized, and the same smart contract will look like much more human readable. And the whole verification will be done like in this line and this line. But today, to create a smart contract, you need to develop a schema and develop a Alluvium assembly code separately, and then link them together. So that's how it works today.
Cool.
Well, literally, unfortunately, if you are not low-level developer, it would be impossible to do that. It's really, really hard. But again, we need to start with something.
Yeah, it's getting there too. I mean, assembly isn't the lowest level possible. It's one step above that. So,
yeah, kind of.
Guys, there is a question in the chat. How do I do to have the syntax colors for the ASM in the IDE?
I just like today it's done really simply. Let me show you how it works. If you have any of the idea, like I use C-Lion, maybe you use IntelliJ or any other. Here in file types, I just add this assembly thing with the highlighted keywords in this. So I can basically share, I can't export it from here, unfortunately. So it's not a plugin, it's just a custom thing. And I can't do an export, but I can share you the list of keywords so you can just replicate and put that into your IDE environment. But if somebody willing to write some syntax highlighting for Vim or any other common or Visual Studio code, again, just contact me. I will provide you with all the keywords, and it shouldn't be really hard to do. You can contact me via RGB chat. If I wouldn't even see, probably Olga will grab that and update me with this request. And actually, the way you can learn the assembly and the way how you can view which assembly instructions and registers are there is the Alluvium itself. So if you will go to the docs Rust and type and look for Alluvium, you have this Alluvium release. And here you will see the whole instruction set architecture described in general terms. And if you will go into specific operations, you will see, for instance, if you need control flow operations, so let's say arithmetic operations, you will see the definition of their operation. And actually, this is the mnemonic and parameters that you should use, and you will see which registers it should take. And that's the way how you can check the actual thing. The other way, of course, you can always look into the Alluvium itself, source code. You go to GitHub, it's internet.org, Rust Alluvium. You can see here in the instruction set architecture, in the file called instructions, you will see that each instruction have a notation of how it looks in the assembly language, so the mnemonic code for the instruction and arguments. And from here you can basically see, and there is a detailed information, which again is in the docs here. I just closed them, which explains how the instruction work, what it does to the source registers and destination registers. So each instruction is documented in all the details. Even some instructions are documented for each specific argument. And yeah, there is a lot of explanations here. So once again, looking into the docs RS. String operations, byte operations. We will see put. It specifies which arguments it takes and different flags. For instance, in some cases, you have quite complex flag set. And here it's all explained in the documentation. Again, you have to spend a lot of time looking through all of that so far. But with the time, I think that it will become more and more high level.
And the same goes for Contractum, right?
Oh, with the Contractum, it's easier, much easier, because you have just a single place to do that. However, the Contractum is not yet developed. So more like a very early prototype and concept. And if I will show you for the Contractum, you just go to GitHub, RGB.org, Contractum link. And here it is, the description. And if you look like RGB fungible token, you will see some code with the comments. And that's all what exists, basically. There is no compiler yet. It wouldn't take a long time to develop and complete the compiler for Contractum, because basically all the problems of creating compiler were solved during this assembly compiler creation. And I just use the same code base to do more advanced language. But I am not planning to work on that before the release of RGB, because I have to focus on other things. And the release will happen in 2-3 months from now. So the continuation of the language development will follow after that. So for now, we have just a prototype. You can read it. And of course, I welcome you to watch the presentation from 2 weeks ago, where I get into all the details about the Contractum, how it looks like, how it works. was called RGB programmability. Olga probably will share a link there. And in RGB programmability, I was giving the explanation of starting from how RGB work to how you define the different data types with the contractum. Data types exist, how you use schema, explaining how the actual code looks, and I was explaining all these details about the internal contractum structure, what types of state transition exist. So there were a lot of material which you can dig into. What was about 2 hours presentation. The next week, I'm planning to do a detailed presentation about RGB roadmap, where we are today, and what is left to be completed before the release. What is the estimated timeline for the release, and what would happen to RGB development after the release. So it will be quite a large presentation, and everybody who is interested, including, I will cover also those questions like what you can do today and what you can do with RGB after the release. You're welcome to that presentation.
So it'll be like a 5-hour presentation.
Not 5 hour, more like 1 hour, 1.5 hour presentation.
2.
No, not two.
But it's gonna be in 3 weeks from now because of the bi-weekly schedule that we have, and also because we would be participating in one of the conferences next week.
Yeah, so it will be in 2 weeks from now. Yes.
Which conference are you going to be at?
The Crypto Castle one in Germany.
No, not familiar with that one. I met BitBlock Boom this weekend, so I think you came to this last year, Maxim.
Sorry, can you repeat?
Nothing. I was just chatting. Sorry.
Okay. Yeah.
Well, we cannot basically. It's hard to travel to the States these days.
Yeah. It's. I literally wouldn't even try to.
Yeah, it's pretty complicated to go across the border, even here across Europe, and it's definitely much more pain in the ass to come to the States these days. So unfortunately, I was planning to actually visit Bitcoin Boom, right, this year, but due to the COVID restrictions, it's become impossible. But let us know how things would be there, and it would be fun to know how the conference went.
Yeah, if I make it to your thing in a few weeks, we'll see if there's time to give an overview of what went down here.
Awesome. Thanks.
Okay, I think we can have quite a short call today, unlike all of other calls. Less than an hour.
Mm-hmm. Sure. I'm gonna post the videos from the last call and from today's call today, but a bit later. Sorry for the delay on this part.
Oh, the video is not yet published. Okay.
It's not yet. Yeah, it's not yet.
You can check it if
Yeah,
you are interested more in contractum and high level stuff. Yeah.
Okay, so thank you guys. If you have any questions, you know where to send them, and thank you for being with us today. See you in 2 weeks. Bye bye.
See you. Bye bye.